Okay, good morning everyone, I'm Ren. Today I'm going to present a concept proposal of the Comfort Zone project. It is an earth-sheltered residential house. Sorry. The proposed size is larger than a standard Australian house. One second. Yeah. Since the building an earth shelters require digging a large deep hole, therefore more surround area is preserved for construction. In order to protect the house from a cool and dry weather climate in Australia, the house is north orientated to gain the maximum sunlight. Wind, in terms of ventilation, is not mainly focused on temperature control, but also inlet fresh air, which is a critical factor to avoid damage in this kind of construction. So this is the concept model. House construction is fairly easy because dust can be usually removed with little or no blasting. The house front is slightly sloped downward toward the entrance from the road. The path is covered with peats, which are filled with grass here in order to have a better drainage. Only 30% of the house structure exposed to the exterior. Remainings are covered in the earth. The design should not be conventional in order to meet the challenge of uniqueness. There are some critical design elements in the structure, such as greenhouse is attached, which induce heat retention and improve the ambient microclimate of the house. It is especially effective in cool and dry climate in Australia. Good design must balance the positive function of windows, that is, penetrate of light, sun, radiate heat, ventilation, and direct eye contact with outdoor. A patio is built in the middle of the house. It is not only open to the proper orientation, north here, allowing maximum sunlight, but also connects the house together. So what you see in the elevations here are parts of the building which are above the ground level. However, the house is actually dug into the ground for around 4 meters deep. The lower floor is designed as a family center. Rooms are smaller than upper level in order to support loads. Upper level is designed as an activities-based rooms, such as office, living, and dining, and there is also an indoor garden as well. Underground structure need to be stronger and massive than the above ground one. Concrete is the major material of the building, which can minimize the extensive loss associated with fire and low-cost maintenance for the house. Vertical loads are the primary concern since soil absorbs and stores moisture. The soil saturation level will then increase. As a result, it will create a higher pressure to the structure. The diagram here shows how the heat is gained through the radiation in winter and prevent from the roof eave in the summer. Also, as I mentioned before, the greenhouse is used to gain heat which from the sunlight and then released to the house. Ventilation. If effective ventilation to eliminate entirely odor associated with dampness. Wind captures is used here to let the prevailing breeze flow into the house. The wind catcher has four faces to catch the wind from different directions. Weight of soil is considerable in the design. It is not only affecting the load, but also affecting the type of vegetation to be planted. For example, the walls and the roof systems here, a small details already help to reduce the soil needed to achieve the same insulation result. Lastly, I will finish my presentation by showing some rendered image. This is the entrance. It is designed to minimize the bias and claustrophobia associated with subterranean living. The massive natural lights help to create a pleasing living room in the upper floor. Although now we are in the indoor section of the house, there is still a direct eye contact with the outdoor view. Patio. It functions as an indoor living space. Passively, it tracking the solar heat through the glass roof, which built to oriented to the sun to obtain maximum heat throughout the day. The second living room in the lower floor. The interiors in the lower floor is designed to avoid narrow, dark, and small spaces. As mentioned in the previous assignment, this project has potential to create a visual comfort environment. In the view here, we can see that there is a neighbor-free view from the roof garden. This is the end of my presentation. Thank you for listening.
Thank you so much for presenting.
No worries.
First of all, I think you did a really good job, and this is really extensive approach. So you covered so many different aspects of a design project. So from the concept itself, the concept of comfort, all the way through spatial design, but I think that maybe the most important thing is that you touched on, and not just touched on, but it's I think it's really well developed, the technical and the technology, if I could say, the technology aspect of a design project. So
yes.
Because the typology you've been using is really particular. You know, the subterranean houses is actually really complicated and a complex typology to deal with. So I think that's the most important part, that you were able to, to manage actually, and I think you manage it well. I'm not by far, I'm not an expert in the typology itself, but I had a few, I don't know, brief moments or experiences with the typology before, so I'm yeah, well, at least I know what it's all about and how it should what the principles are and how it should be developed. So looking through that, I believe that at least most of it you try to incorporate into the design. So of course there's always details that could be developed better and or not better, but just more in depth. But thankfully, there's some time left for that to be accomplished. So while I'm flicking through the presentation, do you have any ideas? What would you like to do next? I'm just trying to see that.
There's still a lot to like work with. I think this is an can't be finished stuff. Yeah, but I'm going to create more details related to the structure constructions, like even how the walls, or even like as I mentioned before, the thickness of the soil even affects a lot of things. So I still keep reading and then accumulate what I know about it, and then to pick the best one for this kind of residential house.
Yeah.
Yeah.
So is that something that you're into? Is that something that you're interested in?
Yes, of course.
The moment.
I'm interested in that kind of like technology and technical stuff of architecture.
Okay, cool. I'm just checking because I think that all of you, not just you, sorry, but all of you need to be focused on the stuff that you're interested in, like the stuff that you really care about, so that I'm repeating myself, but only then you could be really able to move forward and to actually learn something. So yeah, if the technology is what interests you, so just keep going. I don't know what else to say. I wouldn't, just keep going and show the progress, and then I could, guide you as I tried to do in the previous assignment. So in this one also. So yeah, I don't know. Maybe if you go also into these solar panels, how much energy actually could you use? How energy efficient would this whole thing be? These kind of explorations could be interesting.
Yes.
Because are you familiar with a passive house?
Yes, I'm
concept?
really
Yeah,
interested in
definitely.
the passive house design. That's why I comes up with this kind of earth sheltered house. I think that is like final version of a passive house design.
Yeah, it is one of the, but yeah, definitely. So if you could maybe just try to also put your focus on how this house could be really passive or like zero emission house, if that's something
Yeah.
that's part of your interest. So like just to cover everything.
Yes.
Well, that's it pretty much. If I think of something else, I'll let you know. But anyway, thank you so much.
Sure. Thank you so much.
So guys, let me check. Is there anyone else left to present today?